right, so today we are going to be looking at piecewise functions. Some of you have seen piecewise functions before in what's called a step function, which you see in example 2. You are probably less familiar with a piecewise function that combines different linear equations, quadratic equations, and different parts of different functions. So here, what I've done already is I've looked at where the function changes. So you notice we have an increasing line on the left, and then at this point where x equals 1, now it turns to decreasing. So this changes from one function to a new function at this value. So what I like to do when I start these writing equations or even graphing equations is I like to highlight what I call a boundary line. So this line separates this function on this side from this function on this side. So what I'm going to end up doing is writing two different functions. So notice it says f of x equals, and then you have this bracket here. So this means that f of x equals, and then you can add any functions in here. So what I'm first going to do is find this function here. So we know that this is linear. So first I need to find a slope. So I'm going to find a slope. And I can draw my triangle here. So it looks like my slope is 1/2. And then I'm going to use a point on the line. So I'm going to use this point here. I don't have to. You could use any point that you see fitting. But I'm going to use a point on the line, and that's 1, 2, in order to write the equation of this. So we always write with y equals mx plus b. So then my y value is 2 on this point, equals my slope is 1/2, that's m. My x value is 1, and I don't know what b is. So 1/2 times 1 is just 1/2. And then I'm going to subtract 1/2 from both sides. So I have 1.5 equals b. I could have also written that as 3/2. That'd be fine too. So if I look at that, that gives me the equation on this side of y equals 1/2 x plus 1.5. I don't really like using a fraction and a decimal in the same equation. So when I write that over here, I'm going to use 3/2. So I already have the f of x equals here. So I'm going to just write down the equation part. So 1/2 the expression part. So I have 1/2 x plus 3/2. So that is the equation that works for this part. Now what I need to do is I need to restrict that. What that means is I need to say what values of x that counts for. So I can see that this goes from all the way -infinity up to x equals 1. And that's why this boundary line is important to recognize. So this equation works when x is less than or equal to 1. When x is less than or equal to 1, that's the equation that works. So now what I need to do is I need to find the equation for the other side. So this equation here, I can use the same point because that is also on the line. So I'm going to make my triangle, and I see my slope is 1, -1. So my slope is going to be -1/1, which is just -1. So if I'm doing y equals mx plus b for that one, and I'm using that point 1, 2 since that's also on this line, I have 2 equals -1 times 1 plus b. So 2 equals -1 plus b. And if I add 1 to both sides, I get 3 equals b. So that tells me that this side of the equation, this side of the graph has the equation y equals -x plus 3. I could also write -1x plus 3. Either way works. So now for this one, I'm going to write that as well. So negative x plus 3, that's my second equation. And now this one goes on this side. So that's x is greater than 1. Now, something that's really important to note here, this one says less than or equal to, and this one says greater than. You cannot have these both having an equal to sign, because that means that you have more than one equation for that value of 1. So I could have written x is less than 1, and then x is greater than or equal to 1, and that would have worked as well. But I can't have both of them with a equal to sign. In the next example, I'll show you kind of how to differentiate between using the equal to and the just greater than. So let's look at the domain of the function. Domain of the function, remember that's our x values. So our x values, I'm looking at what values go to the left and what values go to the right. So if you look at this equation, it has arrows on both ends, which means every x value is covered. So I can say negative infinity to infinity. The range, those are your y values. The range, I'm looking at how far up and down it goes. I notice that both of these arrows are going down, and there is a maximum value. So I have a minimum of negative infinity and a maximum of 2. I close the bracket since that's a filled in circle and it's included. And that's your interval notation. I could also use an inequality, which you will see me showing both ways. I could use the inequality, y is less than or equal to 2. That works. Now this here, continuous, is kind of a new word for you. Continuous, the way I like to show this is just, can you trace this graph without ever having to pick up your pencil? And the answer to this one is yes. Notice there are no jumps. You can trace it with your pencil. This one's a yes. As a sneak preview to your next one, just to show the comparison, notice this one, if I wanted to trace this graph, there are jumps. Notice I have to pick up my pen in order to trace it. This one would not be continuous. I'm going to cut this video off here, and then I'll make another video for example 2. So make sure you go back to the assignments page in order to find that one.